don't come for free. So you will have to do some small stuff. So be in kind of practice, exercise, do some fun stuff, and then you can collect all the different kind of things. So enough said. I will leave the floor to Craig, and I would like to ask you to have your keynote speech. Thank you very much.
Testing, 1, 2, 3. Good morning, welcome. Usually when I start these, I usually try to start with some bad joke because that's my hobby. So a man walks into a bar and he goes up to the bartender and orders a triple shot of whiskey. And the bartender says, "What's wrong?" And he says, "Oh, I'm so depressed. I think my wife is going deaf and she can't hear me anymore." "Well, that's too bad," said the bartender. "But, you know, don't jump to conclusions. Why don't you go home and actually measure how far away that she can hear you?" "Oh, that's a good idea," says the guy. So he goes home and he walks into the front door of his house and he sees his wife in the living room. And he calls to her and he says, "Hey, honey, what should we have for dinner?" Nothing. Closer. "Hey, honey, what should we have for dinner?" Still nothing. Third time, even closer. "Hey, honey, what should we have for dinner?" And he's really close. He's like this far away. And then he hears, "For the third time, chicken." And I like that joke because it's both the story of marriage and it's the story of people working together. All right. In this presentation, I'm going to move relatively quickly and share a lot of ideas. And the presentation I'll make available to someone here in PDF form so you can get it later on. So first of all, just a little bit about my background for those of you who don't know me. I wrote a book years ago on Agile and iterative. It's been a subject I've been involved in for many years. And that led to more and more requests for work. I served as chief scientist for Valtech, helped create something called Agile Offshore, living in India. I've been living in India on and off since 1978. Was invited to serve as the lead coach of lean software development at Xerox and got more involved in larger and more embedded product development. Started to get requests from a lot of different clients who were involved in larger scale product development and wanted to adopt Scrum. And I became interested in the question of scaling, and I became interested in the personal challenge of what does it mean to scale Scrum to thousands of people in multiple sites. And so that became the focus of my coaching, consulting, and work over the years. And had a chance to work with Nokia Networks, Alcatel Lucent, and a number of other large telecom providers. And out of that, ended up writing some books with my co-author Bas Voda, who was on the leadership team of a large telecom group at Nokia Networks, and then served as the lead of the large-scale Agile Scrum adoption there. And so over the years, I've been traveling around the world. I've just come from Milano, working with a telecom group, and I'm going back there after this week. And then after that, I'll be in Oslo, working with a group building video conferencing equipment. And so I go around the world and work with different management groups about the organizational design and change of large-scale Scrum. And my range of experience is sort of this kind of range, maybe with a medium of around 800 people on a product, maybe 5 sites, maybe 10 to 20 million lines of code, just to give you kind of a sense of the kinds of products I work in. And I got tired of answering the same questions all the same time, along with a bus, and so we ended up writing these books to kind of summarize the experiences of our clients and how to do this. And these include this first book here, which is aimed at leadership on the organizational design changes and the thinking tool changes, and then a more operational book for how to scale in terms of multi-site, offshore, design, architecture, product management planning, all when you've got hundreds or thousands of people that need to do large-scale Scrum. But before I get into the details of what I want to share with you today, I want to start off with a caution. In the late 1950s, the first, as far as we can tell, relatively large software-intensive product development was done. This was a system called SAGE in the United States. And the development went on for several years. It was way over budget and way over time. And when it was finished, one of the original lead project managers was asked for this big original SAGE project, this first big software-intensive development. Question: if you could do it all over again, now that you have the finished experience in 1961, I think it went from 58 to 61, if you could do it all over again, what would you do different? And this is what he answered. He said, I would find the 10 best people and write the entire thing themselves. And I want to stress this because we're working and speaking in a context of large scale. But really the first and important question to ask ourselves is, why do we believe that we need hundreds or thousands of people in order to create a product? Yes, for sure, our products are large, and yes, for sure, they're going to create a lot of people and require a lot of people. But the usual mentality that I see in a lot of the companies that I work with is that essentially what we're doing is something like manufacturing donuts on an assembly line. And it's essentially a resource management problem where if you just throw more bodies at the problem, that will solve the problem. And notice the terminology that we use. We talk about resources and head count, as though the people involved in this were just machine parts, instead of really recognizing the unique and powerful and almost non-linear influence of people on the impact of product development. And so I'd broadly like to encourage you to think about designing and developing systems with small numbers of really great people instead of large numbers and trying to solve the problem with a kind of a factory model mentality. And these issues of how do we solve the problems of scaling really boil down to problems of our mindset, our beliefs and assumptions of how things work in terms of the linear or non-linear dynamics of systems at scale and how to organize people and so forth. And that's why our first book is really about thinking tools and organizational tools. So it really boils down to what's in here. And coming out of that comes all of these things, really. Now, I want to start this presentation by sharing with you some of the core ideas of Agile and Scrum. Why? Why not just jump right into a scaling discussion? Because I notice that it's especially at scale that the core basic Agile values and Scrum concept sometimes get lost. Because the organization is so large, everyone is kind of fixed in their thinking and assumptions at a large scale. So we need to start thinking about just basic Scrum and the implications for that at scale. And let's start with teams, which is talked about more in this chapter. Please read this. In the late 1970s and early 1980s, two researchers named Takuchi and Nonaka looked at the research into the organizational design in product companies that was associated with good things. And they looked at case studies from basically 78 to the early 80s, and then they summarized the results in this paper. This paper published in 1986 in the Harvard Business Review called The New Product Development Game. And this is where the roots of Scrum come from. Scrum is not just a sort of an artificially made-up system. It arose from people, first of all, reading this paper. And so what were some of those qualities? Well, of course, iterative, overlapping, and incremental development rather than a sequential life cycle. And secondly, and especially noteworthy, to quote here, the end of traditional notions of division of labor, rather shared division of labor, where each team member feels responsible for and is able to work on any aspect of the system, in which these people demonstrated multi-learning, so that people were what is sometimes called T-shaped workers. So they have some primary skill, which is especially deep, but they're also working on secondary and tertiary skills so that they have breadth as well and that they can move to new areas. Self-organizing teams, this strong emphasis in the organization on learning, experimenting, teaching other people. And if you understand Scrum, you can see that many of the roots and qualities in Scrum are summarized in the quotes from this Harvard Business Review paper. And so why was it called Scrum? Well, in rugby, this is a scrum. And the metaphor is well chosen because it implies multiple things. First of all, it implies that the whole team is together. There's not separate teams. There's one team trying to move the ball down the field together, where the ball represents, metaphorically, the delivery of value or the delivery of feature, as opposed to single-function teams. Secondly, it implies that it's okay to have people with specialties. This person here might be especially good at running. Maybe that person's especially good at kicking. But nevertheless, they'll all help with whatever the work needs to do. Right now, the work is pushing, and they'll all help with pushing. So the way I sometimes like to summarize the story, imagine that this water bottle here is the ball in the game of rugby, and this represents the goal line that we have to get the ball across. And so the ball's going this direction, it's close to the goal line, it's just down there on the ground, and I run up to the ball, I'm trying to get it this way, I'm the first one to the ball, and all my other teammates are farther back. And I look at the ball, and then I go to my pocket, and I pull into my pocket, and I look at my business card. And it says, Craig, kicker. And I say, oh darn, my job title says I'm a kicker. So I better not pick up the ball and move it across the goal line, because that's not my job title. And he's faster at picking up balls, and he's faster at running. And of course, the most important thing is that everybody does the thing that they're fastest at. So I'll wait for him to come and do it because he can do it better than me. He can do it faster than me. Let's wait for him to do it because he can do it faster. And this is the fundamental thinking mistake called local optimization as opposed to systems optimization. And it's this key conceptual mistake that I see especially in telecom companies all the time, where people mistakenly believe because they look locally, and when a person doing one skill, DSP programming, FPGA programming, Java GUI programming or whatever, when you look at that one skill specification, it looks like the person can do it fast and well, and in fact that's true. And ironically, it's precisely by that single single specialization that when you stand back and look at the whole system, the system delivers slow. Because the dominant force in the system is not the local worker's one task, it's the flow through the system and the bottlenecks that arise from that. And what's really dominantly needed if we want to be able to deliver fast and have the agility to respond to change is that we need people who are willing to say, you know, my job title is primarily kicker, but what's really needed right now is moving the ball across the goal line, and I'll do that and help move it down. Because what matters is not my job, what matters is moving the ball down the field. And in fact, ironically, if to move the ball down the field, the best thing that could happen is that I just stand here 90% of the time, do nothing, lazy bastard, just doing nothing 90% of the time, so that when the ball comes to me, I'm able and free to move it. That's actually the best thing when you look at the system rather than at the individual. But what we get in organizations is things like resource management, where the mistaken belief is that for an efficient organization, everybody should be busy and everybody should be doing their one task. This is the thinking mistake of local optimization. And the metaphor of Scrum is suggestive of that mistake. And so, in large traditional telecom organizations, before they adopt Scrum, you'll usually see something like this. All of these single specialist groups where the illusion is everyone is being productive because everyone is busy doing the one thing that they're good at. And then this gives rise to this fossilized structure of single specialist groups. Now, when we adopt Scrum, what we want is something like this. We want multi-functional, cross-functional teams, and we want people that can go to where the work is. And so the first big step in adopting Scrum is the dissolution of these separate departments. And that has implications, for example, on managers of those groups. What do they do, for example? That question needs to be addressed. I'm not going to pick it up right now. And these people's career paths. I was a junior tester, and now I'm a senior tester. What's my career path? It raises questions like that. Again, I'm not going to pick that up now, but all of these more detailed questions I'll be glad to discuss this afternoon. And so it's important to understand that Scrum is not for this group. Scrum is not for Component 1 programming group. And it's important to understand that Scrum is not a practice. It's an organizational design with implications in terms of structure, roles, responsibilities, relationships, interactions, and so forth. Because what Scrum really implies, at least from the viewpoint of the structure, is the elimination of these single function groups, and then the creation, first of all, of reorganizing people into these cross-functional teams where we draw from these different groups. And now we have the beginning possibility of a nascent team who can do more complete end-to-end work. But when you do this, you'll still have the mindset of my single specialty. This is the starting point. And those of you who are Scrum Masters working with young teams know very well what I'm talking about when I say that one of the first dominant problems in the transition to Scrum is that this person here still thinks that they're the specifier, and this person here still thinks they're the Component 1 programmer. And breaking people out of that mentality into multi-learning is a dominant challenge in the starting adoption of Scrum. How to do this? People often ask me, how long does it take to move from that to that? And the answer is 3 hours. So I like to tell this story. Some years ago, I was working in Hangzhou, China, at a Nokia network site. And there was a group that was making this transition. How to do it? The people, and I can't remember exactly, but there was maybe, let's say, 150 people. 150 people were invited into a room like this. And It had been explained to them, the ideas of Scrum, the motivation why we were doing this. The session started off with the manager explaining what we were looking for, diversity of skills, diversity of experience, and so forth, and then invited the team to figure it out themselves, and then left the room, and the group had the morning in order to reorganize into cross-functional teams. And this was done again recently by a colleague of mine in London, England, where a facilitator played a role where in 15-minute cycles we would set the clock, the 150 people would experiment in trying to form new groups, and then after 15 minutes the new temporary partial groups would reflect upon whether they were good enough for a 5-minute period, and then there'd be another 15-minute cycle of reforming and exploring new groups, and that cycle would go on for 4 or 5 times until finally the new groups had settled down. So how long does it take? 3 hours. If the management knowledge is in place, if the leadership understands why we're doing this, if the leadership has committed to doing this, then actually pulling the trigger on this and making this transition can happen in a very short amount of time. And then the next step of the challenge of adopting Scrum is moving these people into becoming T-shaped workers or multi-learning, multi-skilled workers, where people being T-shaped do have primary specialties, but also now have secondary and even tertiary specialties. And then they have flexibility to go to the ball and help pick it up and move it down the field, even if they're not the best at that, because what matters is moving the ball down the field, not my job title. And what about these groups, product management and program management? Let's explore that a little bit. And this is moving into a discussion of what's called the contract game. And this is discussed more in our product management chapter. The third Agile value is customer collaboration over contract negotiation. And this third value is sometimes misunderstood as only applying to commercial contracts between external customers and the company. But the implication of this value is much broader, and it really refers to all forms of contracts between different parties, even within an organization. Let me explain. So to be clear, this value refers to the internal contracts created between, for example, product management and R&D, not necessarily an external contract with a customer. So in a typical telecom company, you've got something like this. The external customer and an external contract is set up between product management and/or account management and the customer. And that's perfectly fine. That's perfectly ordinary. We're not talking about eliminating that, though, of course, if you can increase flexibility there, great. But what I want to explore is the fact that what happens in addition to that external contract is that, we'll say product management, but I could mean other business groups as well, that product management then takes this external contract and transforms it into an internal contract between product management and R&D, often program management and R&D, but sometimes it's other groups. And if they do this, if they transform this external contract into a second internal contract, what happens? So let's talk about the traditional game of development, the traditional contract game. And in this game, there's 2 major milestones, start and end, 2 major parties, which we'll call R&D and product management or account management, playing the role of business and engineering. And added to this game is a third milestone called content freeze, where some kind of a document is created where the release content is agreed upon between this party and this party. And this is the internal contract that's a reflection of this external contract pushed inside of the organization. And in every telecom company I've worked in, this is usually associated with some kind of a toll gate or a milestone. At one company, it'll be called E2, and at another company, it'll be called H2, and at another company, it'll be called T2. But the only thing that changes between every telecom company is the letters. That's about it. And at this point will be this agreement between product management and R&D of what you're going to do and when you're going to deliver it by. Now, after this point that we'll call content freeze, and of course it's not really content freeze, it is possible to modify this afterwards, but afterwards there's friction about modifying it and it's considered the exception rather than the norm, then at this point, there's a handoff of responsibility from business or product management into R&D. And so after this handoff, from the business perspective, there's a reduction of control, because now the business people, if they wanted to change something, have lower control. There's lower flexibility as well. You might not believe this, but I worked once with one telecom group where shortly after this was agreed upon at the T2 toll gate, the business group realized that the entire product release was invalidated and no longer made sense. And do you know that the R&D group still implemented the entire release, even though the entire business thesis was completely invalidated? Why? Because the program and R&D managers, their performance review and bonuses at the end of the year were defined by HR as being related to how much this contract was correctly met. If something like 95% of the agreed upon T2 contract was met by this date, the senior managers would get some kind of a performance approval and an increase of salary and a bonus. So it's interesting to see how organizational policies can inhibit actually doing the right thing and inhibit flexibility. So there's low control and low flexibility from business's point of view, and there's low transparency from business's point of view after this point, because there's lots of single specialists doing partial work, there's big batches of work, and also you can't release early. There's a lot of balls in the air, and it's not done until the end. So that's the situation of the traditional contract game. And in this development phase, the contract is controlled by R&D. The order of work is decided by R&D, often program management. Product management does not have much control, and there is low visibility into the status of true progress. And then sometimes during this phase, you even introduce ineffective bonus schemes and tracking to plan behaviors that are injected, since there's no real control or real visibility. So in order to create an illusion of predictability and an illusion of control, we introduce semi-fake systems like big plans and schedules, and then we give the appearance that we're following them during status meetings, because the way you're supposed to play the game is that you're supposed to be on plan or on track. But with R&D being a domain where 25 to 50% of the variability is systemic and can't actually be really resolved, there's high levels of inherent systemic variability. Of course, that status meeting and being on plan is not really true, because high levels of variability are the nature of the game. And so then what happens if there's a status meeting at this point and someone asks me, a simple programmer, how things are going on, I'll probably say to my first level manager, I don't know what the heck's going on. It's just a big mess here. I have no idea how we're going to get this done. And then the first level manager preparing for the status meeting talks to the 7th level manager, giving them the status of how things are going on, and the first level manager says to the second level, well, you know, according to the teams, things are kind of rough, but we're managing the problems. And then the second level manager talks to the third level program manager, who's going to meet with the business people to summarize how things are going on in the group, and the second level manager says to the program manager, yeah, basically things are on track. We're doing some good risk management for the minor issues that are arising. And then the program manager talks to the business people, and the business people talk to the CIO, and before you know it, the product development is glowingly perfect and everything is wonderful. And that's because the whole game is that we're supposed to be following the plan, and being on track implies that we're under control and that we've got predictability. Now, of course, this is an illusion, but because the reward and punishment system is all about being on plan rather than actually effectively responding to change. Therefore, there's a reduction in transparency. And because there's a reduction in transparency, then you can't really see what's going on. And then you can't actually control things. So ironically, precisely by the systems set up to ostensibly improve control and predictability, we reduce control and predictability because the game is set up to reduce transparency and to punish people when they admit the variability that actually exists. And in Scrum and other Agile methods, on contrast, we are based upon the recognition and admission that variability exists, and then we work with that variability. Furthermore, after this point, because product management and business doesn't have a lot of control about what they're going to get in, what they do negotiating up until this phase is that they go more, because they basically get one big chance to get what they want into this contract, and after that it's difficult, and they know they don't always get what they want. And similarly, R&D program and senior management, they're going to be held accountable for meeting this content by this date, so they say less. And so we go more, less, more, less, until we hit the T2 toll gate. And what does the T2 toll gate really represent? It represents the time when both parties have maximized the ability to shift blame when something goes wrong. And I'm not being sarcastic. Although you might not have thought about it, that's actually the nature of the game. It's set up to optimize for shifting blame when there's a problem, when both parties basically feel equally dissatisfied, as lawyers say in traditional negotiation. Now, isn't this interesting? In game theory terminology, what we have here is a two-party competitive game, to use game theory terminology. And isn't it interesting that in one company, we have two-party competitive games, even though in theory the CEO says we should be all on the same page and pulling in the same direction. But the organizational structure itself is set up by the creation of internal contracts in order to create internal conflict and competition. So we're not actually optimizing for delivering value to the customer, we're optimizing on being able to shift the problem and blame somebody else when something goes wrong. So this is a two-party competitive game where we can shift the blame when there's a problem. And now we get near the end, and there's only 6 weeks left. And there's been status meetings all the way through here where basically the program manager said to the product manager, yeah, there's some problems, but we're managing it with skillful risk management techniques because we've been to PMI training, blah, 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 so on and so forth. And you hide actually what's going on. But then we come to 6 weeks left, and the wishful thinking can no longer go on. The program and project management basically had wishful thinking during this period that it would work out, and that by hiding the true nature of the problems, we could eventually smooth things out and deliver. But now there's only 6 weeks left, and the awful truth is going to have to be shared with the business people. And so at this status meeting, the program managers say to product management or account management, there was a surprise. And there's no way we could have anticipated this. We did all the skillful management we could, but now there's going to have to be a bit of a delay, we're sorry to say. We did everything we could, sorry. And then there's, as we'd say in biblical English terms, wailing and gnashing of teeth. And there's pressure where people say, but you promised, you committed, you held your hand over your heart at this point and you said, I commit. And so therefore you should make it happen. And as you probably know, the word commit comes from the Proto-Sanskrit, hidden in the secret valley of Shangri-La for thousands of years, because the word commit, which is some kind of strange word which has the magical power to make the variability of R&D go away, so that as soon as you hold your hand over your heart and say, I commit, the variability goes away and we're making donuts on an assembly line. I call this management by magic words, as though these magic words actually solve any problem. Actually, they do solve a problem, because when this person holds their hand over their heart and says, I commit, then when something goes wrong, the other person can shift blame and say, your fault and not my fault. So it's a system that's optimized to shift blame rather than a system that's optimized to solve the real customer's problem. And it's wonderful. It's a wonderful system if basically this group doesn't want to have to be responsible for the problems. So now there's pressure, customer commitment, big penalties, blah, 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 blah. And then that pressure travels from the program manager who has a meeting with her direct reporting project managers, and the pressure goes into them, you committed. And then the pressure goes from the project managers into the first level team managers, you committed. And then the pressure goes from the team managers into me, the programmer, where they say to me, customer commitment, you promised big penalties, blah, blah, blah. And so then what happens in R&D in response to the pressure, incentives, and penalties to get it all done, because R&D made a commitment to meet the internal contract? What happens? And if you're from business, you should now close your ears and not listen, because I'm going to share a secret which normally we don't let business people know about. And this is the secret called the R&D toolbox. And in this last 6-week period, R&D opens up the secret toolbox and they deliver a miracle. And then it gets delivered. Because actually they're all just lazy bastards who are playing computer games for the last 6 months. And all you really need to do is pressure them enough and threaten them enough, and then they'll finally start doing some real work. So what's in the R&D secret toolbox? Crappy code, no longer thinking about the design, no longer taking the time to learn and teach people, stopping testing, not fixing the weaknesses in the organization, more and more overtime so that the very best people in the organization leave and go somewhere else because they can work anywhere they want and they don't have to deal with a lot of crap, and on and on and on. And so all of this technical debt and then organizational debt is pushed into the organization, and the organization gets a little bit weaker, and then you deliver the product on time, apparently, and everyone says, great job. And we've met the customer commitment. Now, and then of course there's various defects and quality problems and weakening of the organization. And we repeat this cycle again for the next 6 months or 16 months. And the second time through this cycle, because there's now debt and friction in the organization, everything is a little bit worse than the first time. And so we go through this entire game the second time, and the friction's higher, and once again, I commit, you promised pressure, blah, 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 and then more opening up the R&D secret toolbox. And we do this the second time, the third time, the fourth time, the fifth time, until after 6 releases, someone goes, damn, for some reason we just can't add anything new to the product. It's so slow to get anything done now. Why is that? I know, let's outsource it to South Yemen and start the next generation product. So it's important to see that the roots of all of this dysfunction and weakness arise from the existence of this internal contract game and give rise to this technical learning and improvement debt. And what we're trying to do in Scrum is address these root causes. So get rid of this traveling of pressure into the system, which is all a side effect of primarily trying to shift blame when problems happen, rather than really solve the root cause problems. And what happens? This kind of stuff happens. The key message I'd like you to take away from this is understanding that in this traditional contract game, these varieties of dysfunction and weaknesses are a side effect of the game. And then we end with this. Now, of course, I'm painting a simplistic black and white picture, but when these kinds of short lectures that I'm giving, that's the best that I can do. I don't have time to give a nuanced explanation of the situation. But nevertheless, to some lesser or greater degree, you will see qualities of this nature in your traditional organizations. But the third Agile value is customer collaboration over contract negotiation. And what does this mean in Scrum? Number one, there is no R&D contract. It's very important to understand that there's no negotiation between product management and R&D program management, and there's no R&D managers responsible for the release. This is the idea of the product owner who's from the business side rather than the R&D side. That's a very important thing to understand. There's an external contract, but we eliminate this whole model of internal contracts, and we eliminate this model of R&D managers responsible for release. This is one of the big ideas of Scrum. Scrum's got nothing to do with these trivial minor ideas like having a meeting every day and so forth. Scrum is about much bigger organizational design changes. And that's why, for example, in the first book written about Agile development, with the word Agile in the title by Alistair Coburn, the subtitle is called The Cooperative Game. Because we moved to a new model where now there's a role called product owner. And this product owner is the person from account management or product management who previously was going more. They're the person who has the external contract problem, so we give them the steering wheel. In the traditional game, the person who has the external contract problem, we take away the steering wheel from them, we take away their control, their flexibility, their transparency, and we shift it all to R&D management. One of the big ideas in Scrum is that the person with the external problem is given the steering wheel, and they play the role of product owner. And they interact with the teams directly every sprint and say, this is what I would like. And then the teams implement well-done work at the end of each sprint, and then the product owner, the business person with the real business problem, inspects the results and then changes direction or stays on the same direction based upon these feedback in short cycles of highly visible, well-done work. So the Scrum product owner is from the business area, like the head of product management or head of business line. They're the investor. The product owner has the responsibility for the external contract, so they have the steering wheel to drive, choosing and changing the content and date each sprint. This is a key thing to understand in large-scale adoption of Scrum. Because in large-scale adoptions of Scrum, I sometimes see this kind of fake Scrum where the traditional game still exists, and incorrectly somebody believes that the adoption of Scrum is just a change for the R&D group within the traditional contract game. And one of the big ideas to understand is that that's not it. It's the elimination of the contract game and the person who is saying more, taking the direct control of delivery. So now, in the customer collaboration model, the lead product manager plays the role of the Scrum product owner. The owner of the product is the product owner, and they directly interact with the Scrum team of value workers with no other levels of R&D managers responsible or in between. So the Scrum role of product owner, they're responsible for the profitability of the product. The product owner is the person who can independently decide and change the content and the date of the release. They're the person with the ultimate business responsibility. And the product owner is not a program manager, not a systems engineer, or some other intermediate R&D representative. A fake product owner is not a product owner. The product owner is the owner of the product, and they steer directly. And I stress this point because in large scale, this is sometimes lost. If the entire company was 8 people, this point is clear to a company adopting Scrum. But if the entire company is 80,000 people and the traditional contract game is in place, this key idea is often lost. And product management thinks, oh, Scrum, that's for the R&D group. Here's your contract. You guys work it out and work more efficiently with Scrum. That's not at all the implication. So it's the end of the contract game, the end of R&D managing the release, the end of business ordering a menu of options from R&D and then sitting down at the table and waiting until the meal is delivered. Instead, we all go into the kitchen together and make up a new dish. Customer collaboration over contract negotiation. A little bit more on the product owner. So they're responsible for ROI, and much more is talked about it in this chapter. We've talked about that. And so the teams in Scrum are self-organizing. So in relationship to the product owner role and the traditional roles of R&D project managers and program managers, there is no project manager or program manager directing the team. This traditional model would have been the product management interacts with R&D program managers who interact with teams, and after you adopt Scrum, it's like this. And I know this might seem repetitive, but I've learned over the years that I have to spell this out very clearly in large scale in order for large scale groups to understand the implications of adopting Scrum. Next, so the product owner from business asks the team to do some work in a sprint, and they do it. Now, at the end of the 3-week sprint, what should they have? They should have potentially shippable product increment, and everyone should know the definition of done. So the idea in Scrum is that if these are sprints, then at the end of every 3-week sprint, the entire product is completely done and shippable. This is called potentially shippable product increment. So it's release done each sprint, so that in theory, the product owner from business could say any sprint, it's good enough, let's actually release it, and there's nothing more to do. So the idea in Scrum is that we can release to the customers at the end of each sprint, though may not. Why not? Because although it's completely done and wrapped up and integrated, tested, documented, it might not be feature-rich enough to be of interest to the customers. And the quality of being feature-rich enough we call minimal viable product. And we need to separate in Scrum this concept of potentially shippable product increment from minimum viable product. Some people mix these things up and think that in Scrum, every sprint has to be a viable product. Not true. It would be nice, but it's not realistic in large-scale telecom. Every sprint, it should be done, shippable, wrapped up, but it might not be viably interesting to the customer because not feature-rich enough. This is a common misunderstanding I've come to see on large-scale Scrum adoptions. The misunderstanding, we must have customer-valuable, minimal viable product increment every sprint. Not correct. Certainly desirable, but is not usually possible, especially at scale. Instead, we should be potentially shippable product increment every sprint, but that does not necessarily mean MVP every sprint. But if the group, if the R&D group is done every sprint and the entire product is wrapped up, integrated, tested, documented, fully end-to-end finished, note, the definition of minimal viable product becomes flexible. And this is what's implied by business agility. Because now if every sprint you're done, then the business people have flexibility in asking and answering the question, when do we want to ship? Instead of the traditional contract game where it's not all done until the end. This is a very big shift in the model. And it's another reason why the traditional contract game no longer makes any sense. Because now R&D no longer is doing a big batch of work. They're just doing a small batch of work, and the idea is, you could say, the end of every sprint is conceptually a potential release. And what's needed to be potentially shippable? This is called the definition of done. This is a very simple example of a real definition of done from a group. Much simpler than in your world. But it gives the idea that in order to be shippable, there's some list of things that we need to do. And the idea in Scrum is that every sprint, that's done. This is a partial example, much more complicated, that actually went on from several pages of a wiki page of a definition of done at a Nokia Networks group that had adopted Scrum some years ago. This was about 800 people in, I think, 6 or 7 sites. And in contrast to this relatively simple definition of done, now it's a lot more complex, divided into different categories like implementation elements, part of the definition of done, testing elements that are part of the definition of done, and so on and so on. But the idea broadly is that you, with the product owner and teams, clearly identify what it means to be shippable every sprint, and then the teams are responsible for getting the product done to this level every sprint. But because in Scrum we fix time is time boxed, and because in Scrum we fix quality, this is our quality story in Scrum, there's really only 3 meaningful variables we can play with, which is time, duration, quality, and scope. And because in Scrum we fix duration and we fix quality, the one variable that the teams play with is scope. So if within the 3-week time box they're trying to do A, B, C, and in order to meet the definition of done, they have to turn off C, they can't do C because of variability, then they would de-scope that and only do A and B to meet the definition of done. Now question, if the team de-scopes C, because time is fixed and quality is fixed, is Scrum the cause of the group becoming later because the team de-scoped C? And the answer is no. Scrum is not the cause of becoming later. What Scrum is doing is revealing the variability that exists inherently or systemically in R&D. And it's revealing that early rather than late, and then giving business a chance to see that early and then respond to that variability. Now, in telecom, typically the definition of done can't be perfect because it's a big product, you're doing hardware and software, you're manufacturing, and it's impossible for some reason to have a perfect done product every sprint. We recognize this limitation in Scrum, and so we recognize that this might be true when a product group, especially at scale, adopts Scrum. This list all the way out here represents the true definition of done, which ideally you could do every sprint in order to be able to release. But when a group starts to adopt Scrum, maybe their definition of done is only to this level because that represents their capacity or their current level of strength. And that's okay to have a definition of done which is less than the perfect. And if this is the definition of done, then that's what the team does every sprint. And the goal of improving with Scrum is to evolve and extend that over time. And if there is some part that's not doable every sprint, we call this the undone in Scrum. Here's another picture of a real done and undone list. So this particular product group could not do performance testing and end-to-end QA testing and full UAT every sprint. And so that was formally part of what's called the undone. And then this is what they did do every sprint. This is not desirable to have this list of undone, but it's the art of the possible. Now, this potentially shippable product increment, if you can do this or do something closer to this every sprint, this has deep implications for business flexibility, such as documents don't crash. And by doing something full cycle across the entire spectrum, we get richer feedback. And so you get all of these benefits with something close to potentially shippable product increment every sprint. That leads to the question in large scale that almost certainly in large scale telecom, you won't be able to get everything done every sprint. There will be some undone, such as stability testing or something like that. So how do you handle the undone? Let's take stability testing as an example of the undone. And this is the Scrum concept of a release sprint. So the problem that we're talking about is, what if the definition of done is not perfect? So what if there's some undone, like stability testing or marketing material or so forth? So if there is some undone, then every sprint, this undone, let's call it the stability testing work, is growing and growing. And it needs to be done before you can actually release. So then the idea in Scrum is to end with what's called a release sprint. And the product owner wants to release at this point, and the product is feature complete at this point, but now there's this undone, such as stability testing, and so then we have a release sprint in which the teams only do the undone work, such as stability testing. Now, that seems obvious and trivial, but look who does it, and this is what is not obvious or trivial. Who does the stability testing or the documentation? It's not a separate specialist group. It's not the stability testing group. It's not the documentation group. It's the regular teams. So the key idea in Scrum is, if you need a release sprint, is that the regular teams shift from working on engineering and creating features to those teams themselves shifting to working on the undone. And this has a very powerful impact on learning and improving, so that it's likely that in the future the teams will be able to do more of this work each sprint and be able to move to something closer to a perfect definition of done, in addition to reducing information scatter, knowledge loss, and so forth that happens in traditional development with a handoff. So a key idea here is that during the release sprint, the regular teams take off their regular development hats and they put on their undone hats. Another variation on doing the release sprint is the following. In large telecom groups, when you're starting to make this change, for some reason you can't get rid of the separate group called the undone unit. And when you first start to transition to Scrum, you've got an undone unit that specializes in undone work with names like the stability testing group and the performance testing group and so forth. And we want to eliminate all those groups, but we can't when we first start adopting Scrum and large-scale telecom for some reason. And so then what do? Then during the release sprint, the teams and the undone unit do pair work on the undone work. And this reduces information scatter and increases learning between these two groups. And then there's two cases. Either you're truly done at the end of this release sprint and then everyone goes back to work, or you're not finished and there's still some remaining wrap-up work, and in that case the regular teams go back to working on the next release of usual features, and any remaining work is handed off to the undone group, which then wraps it up, which of course leads to the waste of handoff and information scatter. And during this period there will be interruption back to the regular teams about bugs that were discovered and so forth. And then this is the usual traditional R&D hell that you're familiar with at the end of a release cycle, but at least it's reduced in contrast to traditional development. And then the journey of Scrum is maybe you start off like this, and then the next step is you get everything done like that, and then the next step is that it's just the teams that can do this, and then finally the final perfection vision is that you don't even need a release sprint because you have a perfect release every 3 weeks. That's the journey of improvement. And another tip is that if you do need a release sprint, consider what we call the rule of 3, which is that after every third sprint you have a semi-release sprint, and in this semi-release sprint the teams shift from doing new features to doing whatever they can to drive down the undone. So for example, if you've got 13 sprints likely in the release, after every third sprint the teams shift and drive down some of the undone, then they do another 3 sprints of normal work, and then in the next sprint they drive down the undone work, because it represents risk and delay, and you don't want to leave it all until the end. like to make a few comments thinking about programmers. The first Agile value is individuals and interactions over processes and tools. Do you have a resource mentality where developers are resources or heads? And you'll hear phrases like, how many resources do we have? What's the head count? This kind of terminology is a signal that that's the mentality in the organization. So like, we need more resources to produce more donuts. Let's outsource to South Yemen because programmers are cheaper there and programmers only have 90% variation in productivity. Do you have this kind of mentality? And I've got no problem with programmers in South Yemen. That's not the story. I'm from Canada and there's lots of bad programmers in Canada. The real point of this story is that do the senior leadership believe that it's okay to shift work to cheaper programmers because there's only 90% variability in productivity? I've worked with various leadership groups in telecom, and usually when I meet with them, one of the questions I eventually ask is, to the leadership team, question, what do you think is the variability in productivity in programmers? And usually I'll get a 75 to 100% variation. Obviously, these good people, smart as they are not aware of the research. Because, for example, this is the summarization of the Kokomo 2 research by Barry Baim. Over 30 years of study into many large software-intensive product developments. And the cover of this book, this is the Kokomo 2 work, summarizes in this histogram the different factors that influence productivity in software-intensive product development. And look at this bar in this histogram here. This bar is basically 10 times bigger than almost everything else, except for the second one, which it's only twice as big as. Look at that, 10 times. Not 10%, not 100%, 1,000%, 10 times more influential on productivity than anything else. And what does the Kokomo 2 research show that that is? Answer, the quality and capability of the developers. Not 50%, not 100%, 1,000% influence on productivity. So if what leadership in any company cares about is productivity, the stupidest thing you can do is just try to hire cheap labor because there's only 50 or 100% variability in programmer productivity. Nothing could be further from the truth. Perkalt's meta-analysis showed that the top quartile of developers is at least 4 times faster than the bottom quartile. And it's hard to find any knowledge work discipline with this extraordinary range of variability and productivity. And it's really quite noteworthy. Remember this quote here, find the 10 best people and write the entire thing themselves. Or this well-known quote by Steve Jobs. Now, in large scale, another thing that happens in traditional telecom companies is what is called component teams. This is talked about in this chapter here. And component teams means you've got groups of programmers that are specialized in different modules. Layer 1, Layer 2, Layer 3, or the device driver group, the GUI group, the platform group, and so forth. And the idea is that we've got private code, and these programmers just work in that code. And then if we have a customer-centric requirement, which actually cuts across multiple components, then we have to chop up the work and give it to them. This is a traditional telecom model, and it reflects the local optimization thinking mistake of keeping people busy doing one thing which they can do fast. But interestingly, when you stand back and ask the question, what impact does this have on moving the ball down the field, then what happens? So what's the problem with this? Well, the first thing to ask is, if this is the situation, who's going to do the requirements analysis? If you've got some feature which is going to cut across, for example, all 6 components, which of these programming teams is going to do the specification and analysis? It's not clear. So what we typically do then is introduce another group before the component teams, which we'll call the specification group or the analysis group. And they'll create some kind of detailed requirements. The next question to ask is, what components are touched? Because it's actually not just 6 components, it's more like 60 possible components, and someone needs to stand back and look at them all and decide which ones are touched by this feature. Who's going to do that? Which of these teams is going to do that? It's not at all clear. So let's introduce another group before the component teams called architects or systems engineers who try to answer that question. And you've got different components and they have to talk to each other. Who's going to define the interfaces between those components? Will it be team 1 or team 2? That's not clear. So let's get this person to solve that problem as well. Then finally, we can chop up the work and give it to different programming teams, and then they do their little part, and then eventually the code all comes together. Now, who's going to integrate this code? Is it going to be this team, or that team? That's not clear. So let's introduce an integration group separately responsible for integrating. And who's going to do the end-to-end testing? Is it that group or that group? Well, that's not clear. So let's introduce a separate group called system testing. And now we've got all of this work chopped up across all of these different single specialist groups because there were component teams, and it's possible that someone could drop the ball on this and lose track of it. So we better introduce feature managers or program managers who can keep track of this all across the groups. I don't know if this sounds familiar to you or if this is a system you've seen. And it's important to see that this model arises from the existence of component teams. In other words, the existence of component teams in single private code groups gives a rise to, what is this? This is a sequential life cycle. This is a kind of waterfall. And if you think you've adopted Scrum and Agile, but all you've really done is superimposed it on top of this structure, you still actually have a sequential life cycle with all of its issues and problems. So note how the organizational structure inhibits change in the architectural structure and vice versa. This is called Conway's law. So the idea in Scrum is to eliminate all of these groups, and when we create new Scrum teams, we pull members from all of these groups. Device driver, Java GUI, platform, and and testing and systems engineering. So then we've got groups that are cross-component, cross-functional, multi-learning. The idea is to move to internal open source. And that leads now to the question of how to scale. And there's 2 frameworks for this called Large-Scale Scrum Framework 1 and Framework 2. So how can one product owner be the product owner for 5 Scrum teams, interact effectively with 5 teams? This is discussed in the large-scale Scrum chapters of our books and really across all 800 pages of the books. Couple of key concepts. First of all, the sprint is for the product, it's not for the team. And you've got one product backlog for the product, not for the team. And you've got one product owner for the product. And that leads to what we call Large-Scale Scrum Framework 1, which works for somewhere between up to 5 and 10 teams and one product owner. How does it work? In Sprint Planning Part 1, there's only one meeting. There isn't a separate meeting for all of the different teams. In Sprint Planning Part 1, and I assume you understand Scrum, I'm not going to introduce basic Scrum in this lecture. In Sprint Planning Part 1, the one product owner comes to this meeting, and instead of all of the teams being present, there's only 2 representatives from each team together. So if there's 6 teams, there'll be 12 people plus the product owner. If it's multi-site, for example, I was working a while ago in Ulm, Germany with an LTE, I think it was M-plane group. 3 of the teams were in Ulm and 3 of the teams were in Wrocław, Poland. And so it was done with Skype video, Google spreadsheet. The product owner has a list of 18 items, 3 items for each of the teams, and says, here's my wish list. And then in sprint planning part 1, just stands back and asks and invites the representatives from the 6 different teams to volunteer for the different items. This is the principle of self-management. You want to avoid people deciding what other people do. Keep things simple and see if the teams themselves can self-manage and decide. Although if there was conflict, the one product owner would decide to offer an item to a particular team. That was relatively rare. Then, moving on to sprint planning part 2, each team does their sprint planning part 2 as usual. There's no special scaling issues there. Daily scrum and coordination. Sometimes one team will go and observe the daily scrum of another team in order to get some lightweight feedback, because the daily scrum is a public event. If the teams needed to coordinate on some daily or weekly basis, they could use techniques like open space, if you're familiar with that, or town hall meeting, or other techniques such as Scrum of Scrums in order to do lightweight coordination. The next major event in Scrum of relevance for scaling is the product backlog refinement meeting. In the middle of the sprint, teams typically spend around 5 to 10% doing detailed analysis and estimation to support future sprints. And in scaling, in addition to the team-level product backlog refinement meeting, we'll add a second joint product backlog refinement meeting that happens before this one. And at the joint product backlog refinement meeting, there'll be 2 representatives from each of the teams that come together, and this subset group will do a partial lightweight analysis across a set of items and do estimation across a set of items. And then that lightweight work is then shifted into more detailed work in team-level product backlog refinements. There's only one sprint review at the end, and how is that done? Well, there's different ways, but one approach is a kind of a science fair approach, somewhat similar to what's going to happen here this afternoon, where there's different tables set up, I think, with different displays that people can look at. And so one way to do a scaling sprint review is that you've got on different tables, you've got access to network elements or higher level software, and the product owner, product managers, account representatives, service engineers, and so forth can go around to the different science fair presentations and actually play with the running system on these different computers. That's one way to do it. We talk a lot more about the details in the book. There's a one retrospective for each team which ends the sprint as usual, but because the team level retrospective is just focused on the team and we want to step back and focus on improving the whole system, then shortly in the next sprint there'll be a joint retrospective where the Scrum Masters and one representative from all the teams come together early in the next sprint, and they look back at the last sprint and they ask the question, how can we improve at a system level rather than just at a team level? And this is called Framework 1, and it scales to somewhere between 5 and 10 teams, and you just keep doing that until you retire. And the details of how you do all of the meetings and design and architecture and so forth are covered in these chapters. Now, Framework 2 is another framework which scales up to at least several thousand people we've seen it apply to. And the key concept for Framework 2 is called requirement areas as a key decomposition element. The traditional way that groups decompose in order to handle complexity is that they decompose architecturally or in terms of functional specialty. They'll say, well, let's decompose into a requirements group and an engineering group and a component team 1 group and so forth. So the way that they traditionally decompose is all inward looking to the work instead of outward looking to the customer. The key idea in Framework 2 is to decompose in terms of what are called the requirement areas. Imagine it like this. You write down on lots of pieces of paper all your customer requirements, you throw them on the floor, 100 pieces of paper, and you invite your customers in to group them into different piles. Now, what groups would your customers create? Your customers would create groups that make sense from their perspective, not related to your architecture or your work, but requirements areas that make sense to the customer. And so what we do is that we introduce requirements requirements areas for scaling, where in the backlog for each of the items, we categorize them into one of these requirements areas: performance, protocols, fault management, and so forth. And some of these areas, of course, are familiar to you already. And then in the product backlog, we can create a filtered view onto it so that each area can be looked at separately. It's not a separate spreadsheet. There's just the one spreadsheet for the product backlog, but we can create views that are specialized into one of these requirements areas. Then we introduce a new role called Area Product Owner. And an Area Product Owner is someone else from product management. There'll be an overall product owner, which will typically be the head of product management for the group, and then an Area Product Owner, which will be some other product manager, for example, for protocols or for fault management. And then a set of 5 or 6 teams will serve that one Area Product Owner. Key point: you must not have one team with one area product owner. Otherwise, you're misunderstanding the idea. One product owner should have something like 5 or 10 teams serving her. Then we apply large-scale Scrum Framework 1 for each of these different requirement areas. So that's basically already been explained. And then we move to Framework 2, which is a set of Framework 1s being done in parallel. And before the Sprint Planning Meetings Part 1 for each requirement area, the overall product owner and the area product owners get together in order to coordinate the priorities and what they're going to be doing in the sprint. And we've seen this scale up to thousands of people and many sites. Now, I want to close off because I've just about run out of time. And I'm just going to skip through this and see if there's anything else that I especially want to make a comment on. Everything that I said up until this point were the key ideas I wanted to share. Question: how many of you know about communities of practice? So not everybody. I'll spend a moment on it then. It's covered more in the coordination chapter. So the idea is that now you have a concern like testing or user interface or requirements. And previously that concern was handled by having a group that worked together on that one concern. Now the groups are cross-functional, cross-component, and so the concern, like consistency of testing or consistency of UI, is now spread across multiple teams. So the idea is to introduce what are called communities of practice. UI community of practice, testing community of practice, and so forth. And these cut across the different teams. You'll introduce a community of practice facilitator who helps grow and have meetings with this group to establish these now cross-team concerns. Design and architecture. This is covered more in this chapter, but the big idea that I want to share is, first of all, you're going to want a community of practice for design and architecture, because this cuts across all the teams. The second is that you're going to want to introduce a technique called design workshops and joint design workshops, where representatives from different teams come together on a regular basis and do agile modeling in order to think about the large-scale architectural elements that cut across multiple teams, so that teams are not just locally optimizing on a local design, but regularly they're standing back and looking at bigger design issues. This is a design workshop in Tempera at the Nokia Networks many, many years ago. That's at Xerox. In addition, we want to document the architecture regularly, the finished architecture. Question: when to document the architecture? Before you implement it or after? Well, after, of course, not before. So after release, we have what's called an Agile Architecture Documentation Workshop, where we get representatives from all the teams together, and then looking back retrospectively at the hardware and the software created over the last 6 or 16 months, they describe it all using the N+1 view model with technical memos, and you set up video cameras, and you have video sessions doing Q&A of describing the architecture for everybody, and then you put this online on a website. I often lead these events. That's actually a video session from an architecture documentation workshop. And so we actually capture in video the questions and answers of people talking about the architecture with each other. Lightweight documentation. We don't want PowerPoint architects. We want a culture of master programmers. And we want a culture of gardening, not building. Software is something organic. It's not like construction. Skip that. And I'll skip this whole section, which talks about splitting big requirements. Multi-site. First, there's a term called dispersed team. This is when one team of 8 people is dispersed into different geographical locations. Don't do that. What research shows, and this is completely independent of Scrum, is that if you have a dispersed team, it's associated with very low productivity. You want this team of 8 people, the Scrum team, to be co-located in the same room. And you don't need dispersed teams when you've got a 500 or 5,000 person group. You can have a set of co-located teams. So large-scale multi-site development doesn't require dispersed teams. You can have a bunch of co-located teams in Budapest and Shanghai and Bengaluru and so forth. And there's a sprint for the product, not for the site. So give a whole feature to a co-located, non-dispersed Scrum team. And if possible, try to organize an entire requirement area at one site, although I recognize that that's especially difficult to do. One of the things to work on when you're creating multiple sites is that some sites can feel like junior partners of other sites. And if you want a successful site strategy, the leadership needs to pay attention to, for example, giving meaningful work to all of the sites so that all groups have a chance to do interesting creative work and feel that they're equal partners. You want continuous integration, and that's not just at the site, that's across the entire world if there's multiple sites. And I discovered over the years of working with different groups that I hadn't used this tool before, but I started to work with some telecom groups which use this version control configuration management tool called ClearCase. I don't know if you've heard of it. And we noticed that it was really, really difficult to easily and successfully do this with this kind of inefficient and poor tool. And in all of our clients where they moved away from this and moved to free open source tools like Git and Subversion, things went so much easier and faster, not to mention saving a lot of money for the company. And you want to increase video if you've got multi-site. But because traditional video tools are expensive, you want it to be free, like especially in quote, low-cost sites, like in India or China or whatever. They're not going to be able to afford expensive stuff. So these days, I normally recommend that just everyone use Google Hangouts. You can have up to 10 sites for free having a real-time video chat with Google Hangouts. It doesn't make any sense to have commercial video conferencing products for that simple, lightweight communication. Although there is a place for expensive, high-end video conferencing stuff for the boardroom. You might not want to do Google Hangouts in the boardroom, but it's perfectly suitable for engineering teams communicating with each other. And you want people from different sites going to other sites and being a matchmaker, helping other people fall in love across the different sites. And you might want a multi-site community of practice. And it's typical that you'll want site-level joint retrospectives. So not just a retrospective for one product group in Budapest, for example, but a retrospective for all of this site, because there's often things related to the local culture or the physical environment that you want to work on. Also, I've noticed when going multi-site that it's especially important to avoid commercial tools, tools that cost money. Why? Because when some group in Helsinki or London starts off and they've got lots of money, they think it's okay to buy a commercial tool. Why not? What's the problem? But then I go to China 8 years later and I look at the group that's now having to be part of this larger product group, and they're not given the 10 million euros necessary to buy these expensive commercial tools, or there's limited licenses, and it creates friction. And I've especially noticed that at multi-site, the more you just focus on free open source tools, the less friction there is and the easier it is to scale. And of course, it's no longer 1985, so I hope you're no longer using Microsoft Word or Excel. You want to move to Web 2.0 models like Google Docs, wikis, and so forth. I think I'll skip this. There's a whole section in here on how to do the adoption and the transformation. But I think I'll just close with some kind of a bad joke. Let me think. A man walks into a bar, goes up to the bartender, orders a triple shot of whiskey, and he's drinking it. And he's looking at his glass, and then plop, falling into the glass of whiskey is an eyeball. A glass eyeball. And he looks up at the interior of this 2-story bar, and leaning over the balcony of this interior of this bar is a woman who says, "Oh my goodness, my glass eye has fallen out. I'm so embarrassed. Can you bring it to me?" "Yeah," he says. So he goes up the stairs with his whiskey glass. He takes the eyeball out. He gives it to her. She dries it off and sticks it back in. And she says, "Look, can I buy you dinner for this embarrassing situation?" And the guy says, "Yeah, sure, that'd be nice." So they're having dinner together, and they're really enjoying each other's company. And then she says to him, "You know, you're actually a really great guy. Why don't you spend the night with me?" And the guy says, "Well, that would be great. I'd really like that. But you know, I'm a pretty plain-looking guy, and women aren't usually so friendly to me right away. Do you treat all the men you meet like this?" And she says, "Oh, no. Only those that catch my eye." Thank you very much.